Hi, and welcome back to the Save It for Parts channel. Today we are doing a video that has been frequently requested on the Starlink Dishy. Now, true to this channel's theme, this is surplus, scrap, and is in fact broken. So I don't know if we'll actually be able to do anything with it, but we're going to start by tearing it down, seeing what's in here, and if it looks like there are some functional parts in here, maybe we'll try firing it up, see if we can connect to the Starlink network and actually do anything with it. Thanks to channel viewer David, who hooked me up with the broken Starlink here. I don't know if he wants his last name mentioned, but thank you anyway. Now, David said this took a tumble off a roof, so there's definitely some physical impact damage to it. I think that there's supposed to be a motor in here that is broken. We've definitely got quite a few scratches and dings on the top surface of the antenna. So yeah, it might be a long shot if there's anything functional in here. Now, in addition to the Starlink unit, we have quite a bit of cable. We have this little modems. We have a pretty beefy power over Ethernet adapter, and I think, yeah, this puts out 56 volts at 1.6 amps, so it's a little bit beefier than a typical PoE adapter. So you don't want to just plug in any old PoE supply, and you don't want to plug this into most PoE equipment because I think it might fry some stuff. Speaking of which, this Ethernet cable that goes up to the Dishy is particularly thick, and it's actually hardwired into the Dishy. And again, I think that's because it uses so much power that it has to be a nice thick cable, nice thick wires in there. They don't want you just running regular old Cat 5 or Cat 6 and potentially overloading something, shorting something out, starting a fire. So this is rated for that high power output because the Dishy here is transmitting up to space. So it needs quite a bit of juice to do that. Let's pop this thing open and see what's going on in here. As with most modern electronics, there are no visible screws. They don't want you to open this up. So you basically just have to pry a bunch of plastic clips out. So here's our motor system. Even though this is a phased array antenna, it still does have some amount of azimuth and elevation positioning, and I think this is probably the main thing that's broken. The motors themselves are probably fine, and these are actually pretty small motors, but they've got these big beefy gearboxes, and I think the broken part here is probably the gearing. Alright, so here's what's going on with the motors. This central pillar is supposed to be connected on the sides here in this plastic cylinder. That has completely sheared off, so this piece here is completely broken, and there is a little bit of wear and tear on these plastic gears. I could probably still salvage these motors for something, and it's possible I could reuse these for some other pan tilt or azimuth elevation mount. Not sure really. Looking down the inside here, no, there's no slip ring, there's no wire wrap, it's just a cable going down the inside. So it just rotates so many degrees of freedom one way or the other way. And this is one of the early dishes, so maybe they did something better with later models, but that was probably good enough for the pre-production and the Dishy V1 here. So let's dig into this a little deeper. We'll take the main cover off. This section right here is actually already popped apart. This is probably where it landed when it fell off that rooftop. I'll have to take the motors off as well. Man, these are really on here. I think I'm just spinning the screwdriver handle instead of the screws. Give that a little stronger science. There we go. All right, we've gotten down to the actual antenna. So underneath this metal plate would be the active antenna array. We do have some damage over here. This is where it hit the ground, so I'm not sure how deep that damage goes, but it doesn't look good. There's definitely, the metal's damaged, possibly just the metal. The PC board underneath here could be okay. So we have the interesting part here from a hacking perspective. So we have the power over Ethernet connector, we have the motor controller connector, and we have this little debug port, and we also actually have a ground TX and RX set of pins exposed. So I believe this is something called UART, which I am not super familiar with, but it's basically a console interface or programming interface where you can theoretically get in and talk to the brain inside here. There's actually a little embedded Android computer with its own RAM and its own operating system. It's running Linux. I've looked at some other people's videos of actually talking to the console on here, trying to get root access, trying to hack into the thing, and that has some challenges. Earlier models were a little bit easier. After a while, Starlink and SpaceX realized that people were doing this, and they have a way of remotely killing parts of this antenna. So there are little E-fuses, electronic fuses in here, which can be blown via software, and that disables certain features. So if they find out that you're hacking their dish, if they find out that people are using the admin console interface incorrectly, they can send down a firmware update that just blows out parts of the circuit board that allow you to do that. So long story short, if this thing is newer than that original hack, then the console access is probably disabled. And if it has been active on Starlink's network since that early console hack was published, then they may have remotely killed some of those features. This is kind of why I don't trust firmware updates. Security experts say, oh yeah, you gotta update your firmware, keep everything up to date, but firmware updates are primarily to benefit the company. They're primarily to benefit big business who sold you to the device. If they benefit you as the customer, that's usually accidental, and a lot of times a firmware update will take away things from you as a customer. It will take away features, take away functionality, and make everything worse. So it's kind of a toss-up sometimes. Do you want to keep your things updated and patched and secure, or do you want to keep all the features that came out when the device was brand new? Now, I'm personally not super experienced with UART and getting consoles on obscure tech like this. There are definitely some other videos out there where people have done that. There are folks out there who have gone as far as building an entire customized circuit board to latch onto this circuit board and glitch out the operating system, basically send voltages where it's not supposed to, send interrupt commands at just the right times to get that root access. That is way beyond my skill level. Now this is something I haven't seen on other teardown videos. There is an SMA antenna connector. Not very many people mention it or talk about it. I found one video where somebody mentions this might be a test port, and it is actually accessible without tearing the dish down this far. This little panel here on the top pops out, and you can get to that SMA port. Some folks on Reddit mentioned hooking this up to a HackRF and maybe being able to see some things. Nobody really seems to know much about this SMA port though, and nobody really seems to do much with it. So I don't know, let's check it out some more. Like I said, the serial port stuff, the UART stuff is a little bit beyond my skill level, but my skill level includes hooking up random things to random antennas, so let's see if we can do anything with this. And I do have a new HackRF one. Now, the HackRF can only see a bandwidth of about 20 megahertz, so it can only see 20 megahertz of the radio spectrum at a time. The Dishy here uses channels that are 250 megahertz wide, so just a quick overview of how Starlink's radio system actually works. They have a frequency range between about 10.7 and 12.7 gigahertz with 8 channels in there. Each channel is about 250 megahertz wide, and so that can carry quite a bit of data, much more data than this thing can even see, much less do anything with. But I still want to see, can this act as some kind of antenna? Can the HackRF do anything at all with this? So I'm not immediately noticing anything. In fact, I'm not noticing any difference at all between the Starlink dish connected to the antenna wire versus unconnected. So basically anything I'm picking up is just coming in from the wire as if it were an antenna. Now this isn't surprising because this is a powered dish, it's a phased array, and probably needs some kind of power to actually activate any amplifier circuits, any down converters, especially the beam forming in here, which I won't be able to use because that's all software controlled. I don't know if I'll be getting any weird voltages out of the SMA connector that could damage the HackRF, so we might start out a little slow. We might throw a blocking diode in there just to avoid burning anything out on my end. I pulled this apart a little more so we can play with it without some of the cumbersome plastic pieces. I'm also aiming the thing away from me. Whenever you're dealing with anything that transmits microwave energy, you basically don't want to aim it right at your head or other soft tissues. And yes, some RF engineer will jump in and say there are rear lobes and side lobes and I shouldn't be running this inside at all, but you know what, I'm more curious than I am smart, so I'm just gonna try it this way. Man, this stupid trapezoid router does not stand up. You can tell they put all the thought into the RF engineering and zero thought into the stability of the physical product. All right, we have power going to the Dishy. We have mysterious glowing light on the Cybertruck thing here. I didn't see any DC voltage coming out of that SMA connector, which is mainly what I'm worried about before hooking up to the HackRF 1. So maybe I'll just go ahead and plug that in while we wait for the network to reset. Well, so far the only effect I can see from connecting Dishy to the HackRF 1 is around 425 megahertz, which seems like an odd frequency, but if I unhook the SMA connector here, we lose a lot of signal right there in the 424, 425 megahertz region. It seems like we're getting some kind of an RF effect here. Don't quite know what's going on, but that's the only thing I've really been able to see on any part of the radio spectrum that this HackRF can look at. Now, in addition to only seeing 20 megahertz of the radio spectrum at a time, the HackRF 1 can only really go up to 6 gigahertz. Now, Starlink is using KU band, which is about twice that. It's up in the 12 gigahertz range. I've been kind of assuming / hoping that the Dishy uses some kind of a down converter, similar to an L&B on a TV satellite dish that down converts from KU band into L band. It basically shifts the signal from 12 gigahertz down to something a little more accessible to common chips and common radio circuits, something more like 950 to 1500 megahertz. I don't know if that's quite the case. That is pretty common with satellite equipment because chips and radio circuits that work directly with KU band are more expensive, more complex. So it makes sense to just down convert and then deal with the lower frequency. And if that's the case, then the HackRF should be able to see that. But all I'm seeing is in the 70 centimeter band, that 424 megahertz, and not in the L band. It's possible that the Dishy is down converting all the way to 70 centimeter, although I think that's a little less common than down converting to L band. Anyway, this is all very conjectural. I don't actually know how the RF circuits on the Dishy work, and I have no idea what that SMA connector is. That might not even be for an antenna jack. That might be to hook up an oscilloscope or some other piece of test equipment. But it seems like I'm not getting much out of it on the HackRF 1. If anyone out there knows why is there an SMA jack on a Starlink Dishy, what can I do with that SMA jack? Is there anything I can do with it? Please let me know in the comments. I would love to find out. In the meantime, we have succeeded in rebooting the Cybertruck. All it really was just single press that reset button. Much simpler than I thought. I was trying to hold down the reset button while I power cycle it. I was trying to do the 6 power cycle thing. No, you just push the button. So now we have the default Starlink access point, the default web page, and we can just set up our own network. I was hoping there was some kind of an admin page I could talk to and get more status, but it's just this anonymous screen. I tried 192.168.100.1, which is apparently the default IP address of the actual dish, and you can get some stats from there, but it's not responding. So either the dish is not working, or Starlink has just removed all user-friendliness and made everything into some kind of app or AI nonsense. Sadly, that's the way tech is going these days. You don't get local admin stuff, you don't get local information, you have to do AI, you have to do special apps. I have like 1,000 apps on my phone. All of those could be replaced by a browser and a web page, but no, every company needs you to download an app, load up your phone, and fill your life with more garbage. And the app doesn't seem to work either. I'm connected to the Starlink Wi-Fi network, but the app still can't find it. I've tried for a while, and this app is pretty useless, and this is why I don't like apps. They're mysterious, they don't always work very well, and they're just another layer of garbage between the user and the product. I guess since we can't connect to this thing legitimately or illegitimately so far, I might as well just take the metal part off and look at the inside. So let's pop this thing open. I kind of know what's inside. I've seen pictures of what's inside, but I want to see if there's any internal damage here where it's been smashed into the ground. You basically just want to heat up the glue that's holding down this metal plate. Again, I don't really want to damage it, but I'm not getting much out of it otherwise, and this is fun. I can hear that glue starting to release. I just need to give it more heat. Yeah, I could use a heat gun for this, but I don't have a heat gun. I have a torch. We do have some internal damage. This is over in that area that hit the ground, and we've got this copper outer layer that's kind of pulled up and damaged. A little bit more over here. Some of this happened when I peeled it off, but there definitely was some existing damage to that layer over in here. I'm not sure if this layer is actually part of the antenna or not. We've got these little honeycomb things here. I believe these are these line up with the antenna arrays on the back of the board, but I'm not actually sure about this part of the copper strip. Is this important, or is this just kind of extra RF shielding? I don't know. So if you have not seen any other Starlink teardown videos, this is what's inside a Gen 1 Dishy. These are all the active antenna circuits. The patch antennas are actually on the back side of this board. So we have our processor, we have some memory chips, we have power over Ethernet stuff, we have those ports, the power over Ethernet port and the motor control port. Then we have that debug stuff. We have a GPS module over here. We have an interesting little skull dude etched onto the board. I don't know if that a little Easter egg for whoever opens the board up to say, hey, you've just destroyed your Starlink Dishy. And there's some more circuit board ASCII art over here. So somebody had fun with the design of this. Yeah, there's another one, and I think that might be Space Invaders. I may not know much about circuit boards at this level, but I am entertained by all the art that's stuck on here. I think that's about it for this video. If the Dishy here was not already destroyed by falling off the roof, I may have done some more damage to it getting the lid off, but I don't know, maybe there's still something we can do with it. If anybody out there has an idea, I'd be interested to try this out. Again, I'm not super great at UART stuff, and looking into that UART connection more, it seems like it needs kind of an obscure voltage. It needs like 1.8 volts instead of 5 volts, and I need to do some pretty tiny soldering to connect any of those pins, which I am not great at soldering, so I don't know if we'll be able to do anything with that. If anybody knows what is this SMA connector, I would love to know that as well. I'd love to be able to use this as an antenna for something else, if that's even possible. Maybe in the future it'd be possible to wipe out the firmware on this and put some kind of custom firmware on it to do something else with the beamforming chips, do something else with the phased array, but that is, again, far beyond my skill level, and I don't know if anyone out there is working on that, but it'd be something interesting to keep track of. I hope this has been a mildly interesting video, even if we didn't really get anywhere with the dish. At least we tore it down, we saw what's in there. I'll throw some links down below to people who actually know a little bit more about this, or a lot more about this than I do, and have done some more interesting things that get pretty technical if you're into that sort of thing. Thanks to everyone for watching, and we'll see you next time.